We're going to prove one of the properties of theorem 6.2. We're going to prove property number 1, that an isomorphism phi carries the identity of G to the identity of G bar. And so the strategy of the proof is going to be, we're going to take E, the identity in G, and then we're going to let E bar be the identity in G bar. And what we need to show is that phi of E is going to be E bar. So that is going to be the strategy of this proof, what we need to do to show that an isomorphism phi carries the identity in G to the identity in G bar. Okay, let's prove that. So proof for 6.2, property 1. So what we just said was that we named the two identities. So let E denote the identity in G, and E bar the identity in G bar. And what we need to show is that phi of E is equal to E bar, so that phi sends the identity in G to the identity in G bar. Okay, so what do we really know? We have to show something about E bar, and what we know about E bar is that it's the identity in G bar, and we somehow have to get phi of E in here. So if I take E bar and I multiply it by phi of E, since E bar is the identity in G bar, I know that it doesn't change phi of E. Because phi of E, I don't know right now what it is, but I know it's an element in G bar. And since E bar is the identity in G bar, when I multiply E bar by phi of E, it's equal to phi of E because E bar is the identity. Okay, so we got that. Okay, now phi of E is the same as phi of E times E, since E is the identity in G. And that is nice because now I can split up my two E's, so I get phi of E times phi of E, because we have an isomorphism, and the isomorphism preserves the operation. And now we have E bar phi of E is equal to phi of E times phi of E. And because of right cancellation, we get that phi of E is equal to E bar by right cancellation. And that's what we wanted to show.